Welcome back to the Datarekha audio guide. I'm Diya.
And I'm Arjun. Today, the single loop that explains everything about how an AI feels to use, why it streams word by word, why long answers are slow, and why a bad first word can wreck a whole response.
So when I send a prompt, the model doesn't think for a beat and then hand me a paragraph.
No? And that mental picture is the thing to unlearn. It produces one token, then another, then another. Each one is a function of every token before it. That sequence is the entire generation process. There's no draft sitting inside that it's transcribing.
Walk me through one full loop concretely.
Take the capital of France is. The model does one forward pass and gets a probability distribution over its whole vocabulary. Paris wins. It samples that, appends it. So now the running text is the capital of France is Paris. Then it checks. Should I stop? If not, it feeds that whole thing, including the word it just wrote, back in and predicts again. Maybe a full stop next. Predict, append, check, repeat.
So the thing it just said immediately becomes part of its own input.
That's the heart of it. Which means there's a hard dependency. It cannot produce token 5 until token 4 exists. Output is inherently sequential. And this is the part people fight. No amount of hardware, no bigger GPU, removes that dependency. You can't parallelize your way out of a chain.
Okay, that has a consequence I want to chase. If it's sequential, asking for a giant answer must be slow no matter what I pay.
Exactly right. A 10,000 token summary doesn't get faster on a fancier machine. Every token is its own forward pass through the network, in order. Total time is roughly the time to the first token, plus output length divided by speed. On current models, you're seeing maybe 50 to 150 tokens a second. So a 500 token answer is several seconds. If you need it fast, the real lever is asking for less.
And I'm guessing this is also why output costs more than input.
It is. Input you can chew through in one parallel pass. All the tokens at once. Output has to be generated one at a time, a full forward pass each. And that sequential GPU time is where the money goes. Output tokens run roughly 3 to 5 times the price of input.
Let me flip to the upside because there's a nice one hiding here. If tokens come out one by one, the API can just hand them to me as they appear.
And that's streaming. And it's the reason every chat interface types the answer out in front of you. It's not a UX gimmick layered on top. It's the literal shape of what's happening underneath. Which leads to the thing that actually governs how responsive your product feels.
Time to first token, I'd bet, not total time.
That's the insight. Users judge speed by when the first word shows up, not when the last one does. 200 milliseconds to first token with steady streaming feels instant. A 2-second silent pause, and then the whole answer dumped at once feels broken, even if that version is technically faster overall. So in anything user-facing, you always stream.
Now, generation has to stop somehow. How does the loop know it's done?
3 ways, and only 3. 1. The model emits its special end-of-text token. That's the natural stop. It's decided the thought is complete. You hit max tokens, a hard ceiling you set. Always set it, or a runaway loop quietly bills you. 3. A stop sequence. You tell it if you ever produce this exact string. Halt. Handy when you don't want it to keep running a pattern.
Here's what I want to nail down. There's a popular prompt recipe. Give me the just-so answer first, then explain your reasoning. You're about to tell me that's backwards.
Exactly backwards. And now you can see precisely why. By the time the model commits to the answer token, it has had 0 tokens of scratch space to think with. The reasoning that comes afterward isn't the cause of the answer. It's a post hoc story bolted on after the fact. The answer is just worse.
Because the tokens it writes are the thinking. So if I want it to reason, I have to let it reason out loud before it commits.
You've got the whole lesson in one sentence. The reasoning you see in chain of thought is real reasoning, happening as the tokens come out. There's scratch space. Put the reasoning first and the structured answer last. And it's genuinely more correct. The order isn't stylistic, it's mechanical.
And the same fact explains why a bad opening token cascades. It can never take it back.
Once a token is out, it's out. There's no self-correction mid-generation, no eraser. Which is exactly why prompt engineering bites so hard. You're steering those first few tokens. There's even a trick some APIs allow. Pre-fill the start of the response. Drop a single open brace at the front, and you force it into Jusso mode far more reliably than politely asking. You're literally setting the loop's initial state.
So the one line to take away?
An LLM writes one token at a time, each one feeding the next. And every quirk, the streaming, the slowness, the brittleness of that first word, falls straight out of that. Get the loop, and none of it surprises you anymore.
It's not thinking then writing. The writing is the thinking. That's the Datarekha audio guide. See you in the next one.